everyone! Today I'll be teaching you how to graph transformations in the vertex form for parabolas. But before we begin, let's review what each variable in the vertex form represents. So A determines if the parabola is compressed, which means that it is wider, or if the parabola is stretched, which means that it is thinner. A also determines the opening of the parabola, whether it is facing upward or downwards. H determines the vertex's horizontal translation, and as I have mentioned many times before, if H is positive, the parabola will be shifted to the left side of the graph, while if H is negative, the parabola will be shifted to the right side of the graph. K determines the vertex's vertical translation. So if it's positive, the parabola will go up, and if K is negative, the parabola will be shifted down. So now that we reviewed, let's begin. So where to start? In order to graph a transformation, you must first be given an equation. In this case, I have given you an example. Y equals negative 0.5 x plus 3 squared plus 3. So, first off, we will be using a method called mapping notation, which is x subtract h in one bracket, and the other bracket is a times y subtract k. So what you do here is you plug in your h, a, and k values. So in this case, it will be h subtract 3, negative 0.5 y plus 3. And you must always remember that the h value will have the opposite sign from the equation. So whenever we are talking about transformations, we must always relate it back to the basic quadratic equation, which is y equals x squared. So what do we do now? Well, now we draw two charts, one being the basic quadratic equation, while the other one is a chart for our given equation. So here's how it will look like. One chart is y equals x squared, while the other chart says y equals negative 0.5 x plus 3 squared plus 3. In each chart, we put in the coordinates for the dots of the points, for the y equals x squared parabola. And as you can see, there is a sort of a pattern. There's 4, 1, 0, 1, and 4. And when you graph it, you will see how it will curve back up, creating a symmetrical curve. Okay, so next. So now we plug in the mapping notation formulas into the chart for the given equation. X and y equal to the basic quadratic chart values. So here's our mapping notation formula, which is x subtract 3 and negative 0.5 y plus 3. Now we must input it into the chart. We apply x subtract 3 to the left side of the chart, which is our x value, and we apply our negative 0.5 y plus 3 to the other side of the chart, which is our y value. So here, x will be what the basic parabola equation point is. So, for example, negative 2 is the parabola's point. So you would plug this into our x's, and you will do negative 2 subtract 3. You apply this to all of the numbers. So after plugging in the mapping notation formula, we are able to solve it. So negative 2 subtract 3 is equal to negative 5. Negative 1 subtract 3 is equal to negative 4. 0 subtract 3 is equal to negative 3. 1 subtract 3 is equal to negative 2. And 2 subtract 3 is equal to negative 1. A quick way to know if you're on the right track is if the x values, they have a constant number. An example of a constant number could be 1, 2, 3, 4, 5. Or negative 1, negative 2, negative 3, negative 4, negative 5. So in our case, our constants is negative 5, negative 4, negative 3, negative 2, and negative 1, which means that we are right on track. Now we solve our y values. So negative 0.5 times 4 plus 3 is equal to 1. Negative 0.5 times 1 plus 3 is equal to 2.5. Negative 0.5 times 0 plus 3 is equal to 3. Negative 0.5 times 1 plus 3 is equal to 2.5. And negative 0.5 times 4 plus 3 is equal to 1. As you can see, there is another pattern. The pattern is how our x values, negative 5 and negative 1, have the same y value, which is 1. And our x values, negative 2 and negative 4, have the same y value, which is 2.5. Now we know that the first and last x value will have the same y value, while the second and the second last will have the same y value, and so forth. After seeing this chart, you are now able to see that once you graph it, the coordinates will turn into a symmetrical curve since they have the same numbers. Also, an important thing to take note of is our middle coordinate. These are the vertex coordinates h and k from our given equation. You know if you're doing your chart right if the middle coordinates match the vertex coordinates. So as you can see, our vertex coordinates given by the chart is plus 3 and plus 3. And since in the chart it's plus 3, it'll turn into negative 3, which you can see obviously, negative 3 and 3. So after completing the step, which is finding the given equation's coordinates, we are able to graph it. So the final step is to plot your points. And after doing this, you must always remember to write down your transformations. So for our example, our parabola translated 3 units to the left from our basic problem. The opening is now facing downwards. It is compressed since A is less than 1 and more than negative 1. And the parabola translated 3 units up. So to sum up this lesson, we first use the mapping notation, which is x subtract h and a times y subtract h. We then plug in our h, a, and k from our given equation into this. Next, we make 2 charts, one being the basic quadratic equation and the other chart being our own equation. We plug in the mapping notation to our given equation. Next, we solve and we graph our points, and then later on we state our transformations. So that is it for learning how to graph transformations, and I hope you understood this lesson and learned something from it. So thank you for listening.